CYBAI shared the Hitchhiker's Guide to the Servo Contributor. Servo is an experimental browser built by Mozilla from scratch with Rust. This time, CYBAI will introduce you from the beginning of Rust to the long-term contribution of Servo and lead everyone into the world of contributing Servo. In this talk, he will talk about what Servo project is, how to contribute Servo, and how to test what you implemented, and how to find talks to do. So, welcome CYBAI. Thank you.
Hello everyone, welcome to the Hitchhiker's Guide to Servo Contributor. So you can call me CYBAI or you can call me Haku, and I'm from Taiwan. And my GitHub ID is CYBAI and Twitter ID is _CYBAI. I currently work as a software engineer at Herb, and our production is we are creating an applicant tracking system, which is similar to Google Hire. And we are trying to make everyone to hire new members more efficiently instead of only through HR or tech leader. And I started to contribute to Servo from August 2017. And this is today's agenda. I will talk about what is Servo and how to contribute to it and how to run tests. And also, I will share with you how the Servo CI works. So, what is Servo? Servo is a modern, high-performance greenfield browser engine designed for both application and embedded use. Embedded here means Android, Magic Leap, and other XR devices. And there are two benefits and advantages for Servo. One is there is no legacy code because it is built from scratch. And the other one is it is written in Rust. And thanks to there is no legacy code, the Servo team can try to design a new architecture and to achieve parallel and concurrency computing and layout. And also thanks to using Rust, Servo derived the memory safety and security from Rust. Servo doesn't aim to be a standalone browser engine. Instead, the Servo team is trying to create move more components into Rust, and after the experimental, it will be moved into for Firefox. For example, in the picture you can see the left side is Stylo, which is Quantum CSS, and the right side is Web Render, which is Quantum Render. The pictures are from the Mozilla Hex blog. They are drawn by Link Clark. So I will recommend everyone to read the blog post to understand more about Stylo and Web Render. And I will demo a little bit about the Servo and the normal browser, about the difference. So as you can see, this demo page, the left, there are two iframes. The left side is a rotating Rust logo, and the right side, it will calculate a 900 multiply 900 matrix. So in a current modern browser, I mean, for example, Firefox, Chrome, or Safari, there is no concurrent or parallel design. So when the left side iframe calculates 900 multiply 900 matrix, when it calculates down, then the left side rotating Rust logo will just stop. So let's check the Servo to see how it works. So there's a make script, and you can use run to use Servo to serve on the internet. So as you can see, the left side is the rotating Rust logo. It's rotated by iterating a for loop. And when calculating the 900 multiply 900 matrix in Servo, the left side rotating Rust logo will not stop. And this is thanks to the parallel iframe design in Servo. So this is the most impressive one for me. And I'm not sure if every audience is familiar with Rust, so I will just introduce a little bit about it, but not very detailed. So let's take a look at the official website of Rust. It says, Rust is a language empowering everyone to build reliable and efficient software. And the most famous and impressive features of Rust is ownership and borrow checker. What is ownership? Let's take a look at this example. Ownership, we assign a string hello to S1 in line 2, and then assign a S1 to S2, and then we want to try to print hello world with S1 in line 5. Usually, if you write this in other language, you might expect this works, but let's see how it works in Rust. When you compile this example code in Rust, you will get this. The compiler will tell you the S1 value borrowed here after move. Here is the line 5, and it will tell you the S1 value has been moved in line 3, which means you have transferred the ownership of S1 to S2 in line 3, and then you just wanna try to use it again. But at that time, the ownership of S1 has gone, so you cannot use it anymore. And let's take a look at how borrow checker works. And in this example code, we declare a string s hello in line 2, and then we try to pass the string s to change function. But in line 8, we are trying to mutate the string by push str function. In Rust, every variables or arguments are immutable by default. So what will happen to this example code? When you compile this example code, compiler will tell you the sum string is a reference, so the data it refers to cannot be borrowed as mutable. And the Rust compiler is very friendly. It will tell you how to fix it. So let's take a look at the help note. You can just see it says, consider changing this to be a mutable reference, which means you just need to add the mut keyword. So this, thanks to the borrow checker, we can get this compile time error in compile time. So what is Rust in very short sentences? I think Rust derives many good features from functional languages like Haskell or OCaml, and the most impressive features are algebraic data types and trait. And also, thanks to borrow checker, you can hack without fear. There's a link to the hack without fear. It is linked to the C++ now 2017. The talk is given by Nico Matsakis. It's a very great talk, so I recommend everyone to watch it. And also, Rust is the most loved programming language in the Stack Overflow developer survey in the past 5 years. So let's get into how to contribute. This is basically the workflow of contribution, but if you currently work as a software engineer in your daily life, then this is basically same as your daily work. So first of all, you need to find an issue, and then after you find an issue, you just need to find the right place to try to fix it or implement the feature. And after you implement it, you just need to test related WPT tests locally. And then you confirm the test works fine or works expectedly, then you can just send the PR. Then you will just need to wait for review. And after review, if there is any comments or concerns, you just need to update your PR. And then after update PR and finally you get a pass, you can merge the PR, then reviewers will try to help you to approve your PR by running the CI. And after running the CI, if there's any failure is unexpected, then you will need to check it. You will need to check if the unexpected failures are related to your PR or not, because sometimes there are some intermittent failures. So sometimes you can just retry your CI, but sometimes you will need to update or find out the root cause. Then in the end, there is no unexpected test failures. Then reviewers will R plus your PR, and after the test approved by R plus, then the bot will merge your PR automatically. And some of you might be confused what is WPT and what is R plus here. So don't worry about the jargons here. I will introduce them later. So in open source projects, when we want to get into an open source project, the most common label in GitHub is good first issue. But for several projects, the good first issue is E easy and E less easy. The E stands for effort. And so if you are a new contributor and you just want to get familiar with the project from very easy issue, then you can try to pick them. Or you can try to pick the candidate for mentoring. It means it might be an easy issue, but a member don't have time to check it very carefully. So they just label it with candidate for mentoring, and they will try to mentor you to finish the issue. And the other one is E-hard. It's just like its name. It's for those who want to find more challenging tasks. And other than the labels, you can also check the Servo starter page. And if you still cannot find any issues you are interested in, you can just find any web API you are interested in. And if they are missing in Servo, you can just try to file an issue and fix it. So before I start to introduce the workflow by introduce this issue, this is my first issue to Servo. And this is very good for everyone to understand the workflow because it just includes many edge cases, maybe not edge cases, but it's a very complete workflow. So might be good for everyone to understand how to contribute. So I randomly picked this easy issue at that time. And basically, this is an issue for a spec update. For example, for this issue, at that time, the DOM spec updated to add an active flag to the node filter algorithm. So let's take a look at the DOM spec. The DOM spec says the step 157 with the red arrows are added for the issue. So before that issue, there's no active flag. And after the spec update, we will need to add an active flag to traverses. And what is traverser? A traverse, we can see the first sentence. It says a node within a node iterator or tree worker might be a traverser. So we can understand that we will need to add the active flag to node iterator and tree worker. Then let's take a look. After we understand the spec and understand what we need to add, then we just need to find where we should implement it. In Servo, there's a very good habit, which is they will add the spec link above the function. So as we can see, the fn accept node is referred to the concept node filter, which is for the issue, and I mean for the algorithm. So we can easily find this function when we want to fix the issue. So after we add a active flag to the node iterator and tree worker, then we just need to add a check, which is very simple. When the active flag is true, then we just return don't exception invalid state error, and then when just like the step 5 and step 7 to set and unset the flag. So after we understand where to fix it, then it might be simple to just add the code. But how can I confirm my implementation is correct or not? So this is about the WPT tests. In software engineer, writing tests to verify the business logic is indispensable. So do the web platforms. And so here comes the web platform test project, aka WPT. Then let's take a look at this sentence from the WPT official website. It says the WPT project is a W3C coordinated attempt to build a cross-browser test suite for the web platform stack. So we can know the WPT project is for all the browser vendors, not only the browser vendors. Maybe if you are interested in contributing to the web platform, you can also contribute to it. So before introducing the WPT tests, I also need to introduce WPT metadata. The metadata is for example, we maybe around 2013, the browser vendors are trying to introduce service worker. Maybe at that time, not any browsers has implemented service worker, but when the spec authors are trying to spec the spec, then they will trying to add a WPT test for corresponding spec. For example, service worker fetch or active or update like that. So before all the browser vendor implement the feature, they might not implement it, but they still need to run the CIM. But at that time, they just need to use the metadata to record the current. They just need to use the metadata to record the test status. So let's keep looking, and you might understand how it works. So after I send the PR and servo member help me to trigger both servo with try. The try command will just try to see if the CI test work pass or not. And after the CI test triggered by try, it will report the test result to GitHub. And as you can see, at this time, the both server report all the tests are successful. But let's take a look at the comment from JDM below. He said there are test upstream that would be affected by this, which means I have updated the spec. I have updated the code to be spec compliant. So there must be some tests were failed, but it should be passed now. So we shouldn't get a test successful here. So let's introduce the relationship between browser vendor and WPT. So WPT is an upstream repo for every browser vendors. So when the relationship between browser vendors and WPT is browser vendors will synchronize the WPT tests every day or frequently, and when browser vendors trying to fix something or implement something, they will try to contribute some new tests or fix tests, and then they will have bots to synchronize those fixed tests or new tests to upstream repo. So after we synchronize the new tests, then JDM helped me to try again. And then we can see this is thanks to the metadata. But before the patch, the tests of traversal tree worker and traversal node iterator was marked as failed because there is no implementation of the active flag. And then after this PR, they are already passed. So I just need to update the metadata of both tests. So after I updated the metadata, JDM just helped me to R+. But what exactly the both servo is and what is the R+? So this is about the servo CI. And Homu is a re-implementation of BOSS, and BOSS is first introduced by Graydon Howard, who is the Rust original creator and mainly applied Ben Edison's not rocket science rule. And the rule is the not rocket science rule of software engineering is automatically maintain a repository of code that always passes all the tests. It sounds easy, right? But sometimes it doesn't. Let's take a look at this workflow. Engineer A sent a PR to rename function foo to function bot, and he or she will get the PR pass, a CI pass. And then engineer B just need to work on some other feature, and he or she just call function foo in somewhere, and he or she just also get the CI pass in his or her PR. It sounds very correctly in the workflow, but because the function foo has been renamed to function bar in engineer A's PR, so when both PR merged into the master branch, the function foo doesn't exist, so we will get a broken master branch. So Homu is introduced to fix this issue. Homu has a queue. So this is the Homu's queue for servo. As we can see, there are two pending running tests. One is for normal approved, and another one is for try. And as you can see, there are 6 approved PRs. So after the R plus approved, they will not directly run the CI. So all of the PRs will need to wait for the running CI to be done, and then they will be executed one by one. So we can safely merge all PRs very safely. And also thanks to this spatial part of Homu, it will always pull the latest master branch with your PR to run the test. So when I just send a PR, I don't need to rebase to the latest master to get the latest tests for the node iterator and tree workers. Then the servo members just need to execute the post servo command to help me to try. So after the post servo with R plus get all tests success, then it will merge the PR automatically. So let's recap. Let's look at this direction between the relationship of the spec authors, browser vendors, and the WPT organization. So when the relationship between spec authors and browser vendors is browser vendors will need to implement the existing spec or new spec, or sometimes when existing feature are updated, then browser vendors will also need to update their implementation. And then when browser vendors trying to implement something, then they might contribute back to the WPT tests for new tests, or some wrong tests will be fixed. And then when the spec authors trying to add or fix some spec, they will try to write some new more spec compliant tests. And the other direction is when the W3C or WG update the specs, then they will also fix the tests. And then browser vendors will synchronize the tests from WPT. And then when the browser vendors trying to implement something or trying to fix some features, they might find some spec bug. Then they will file issue to the WG or W3C organizations. Then after some discussion, they might need to fix some implementations. So this is this directions recap. So this is today's reference. And I have a blog post on blog.cyibai.dev, and there are 3 posts about today's talk. So you can also check my blog series there about servo contribution. And we are hiring. So that's it. Thank you.
Okay, thank you for CYBAI's talk. So because we don't have the live Q&A time, so if anyone have questions, please contact him.
Okay, everyone can add me on Twitter, or just use Telegram is also fine.
Okay, thank you. So we are going to start our next